So today I want to talk about phase changes, like moving from a liquid to a solid back to a liquid. And during a phase change, the temperature doesn't change. All of the heat goes into changing the state, not the temperature. So Mr. Snowman here melted, and all of that heat went into changing his temperature. So Q equals MC delta T is only for temperature changes, not for phase changes. If we go back to our original graph here, solid ice, you can have really, really cold ice, and you can actually have warmer ice, okay? This area of the graph would be Q equals MC delta T. Same with liquid water. You can have cold water or hot water, colder gas or hotter gas, which is kind of weird to think about. These areas of the graph, you'll recall, go straight over. There is no temperature change during a phase change. We call these areas the heat of fusion and the heat of vaporization. So melting is also called fusion. So the heat that it takes to melt something is the heat of fusion times the number of moles of the substance. You'll notice that Q equals MC delta T involves M for mass, and these equations instead use moles, so you'll need to convert. Delta H of fusion is called the heat of fusion, and it is the amount of energy required to melt 1 mole of a solid. The heat of fusion for water is 6.01 kilojoules per mole. That's on the back of your periodic table, or you can look that up. To boil, this is the heat of vaporization. Remember when we started this chapter, I said it takes a lot more heat to boil something than it does to melt something? Well, here it is in math. The heat of vaporization for water is 40.7 kilojoules per mole. So, for example, how much heat is required to completely melt 450 grams of ice? Melting means we're using the heat of fusion. The first thing you want to do is you want to convert grams of ice to moles of ice. So grams divided by its molar mass from the periodic table. Ice is, of course, water. Just to remind you, you've got H2O. Hydrogen weighs about 1.01. Oxygen weighs 16. You got 2 of these. So you're going to end up with 18. That's why we always have this number here of 18 grams. So first convert the moles of ice, and then you can go and plug it into the equation. Heat of fusion is always the same, 6.01 kilojoules per mole, times that 25 moles you just found equals 150 kilojoules. Another thing to note is when you do the equation Q equals MC delta T, it's in joules, and when you do these equations, they're in kilojoules. Here's another example, except this time we're going to use heat of vaporization. You've got 0.44 moles of steam at 100 degrees Celsius. This is important here. We've already reached 100 degrees Celsius. We're ready to boil. Or in this case, we're ready to condense because we're going from steam down back to water. How much energy is required to condense it? So we have the heat of condensation. The only reason I put negative here is because I'm trying to show that it's losing heat. So we just use that heat of vaporization times the number of moles, and we end up with 18 kilojoules. So how much energy is required to condense it? The answer is 18, but you're removing heat. So that's why I'm going to put a negative 18. Condensing is, of course, the opposite of boiling. How much energy do you need to boil 6.9 grams of ethanol? Now, ethanol is going to have a different delta H of vaporization. So I have to include it here in the equation, or you could look it up online or something. So it's telling me my delta H of vaporization is 38.56. So step 1, convert grams to moles. So there's my grams converted to moles. This is the molar mass of ethanol, C2H5OH. 6.9 grams divided by 46 equals 0.15 moles. And now plug it into that equation. 38.56 kilojoules per mole times 0.15 moles equals 5.8 kilojoules. And here's my last example. We're not going to do too many of these in class. because they involve both equations. They're kind of tricky, but I just wanted to show you one example just in case. If you had a glass of water at 22 degrees Celsius and now you're going to heat it, remember you've got your graph here, you've got your ice melts water, boils steam. So in this case, you are water at about 22 degrees Celsius, and we're going to heat it, and then we're going to boil it. So we're going to use both portions of that graph. First, Q equals MC delta T, and then the one we just talked about, the heat of vaporization. So here's my Q equals MC delta T portion, right? That's the amount of energy it takes to heat the water. 100 grams of water. C, this is water, 4.18 joules. The temperature change is from 22 degrees Celsius to 100. This is how much energy it takes to heat it. And then there's how much energy it takes to boil it. I had to convert, of course, the number of moles here. So I have grams into moles. And then I also paid attention to kilojoules. And then I add those two numbers together. So I get a total of this. This is how much energy it would take to heat the water from 22 and then boil the water.